Okay, hi everybody. So today we're going to talk about inscribed angles, section 12.4. First of all, a definition. An inscribed angle is an angle whose vertex is on the circle and whose sides contain the chords of the circle. Every inscribed angle intercepts an arc. So let's take a look at these. So we can see here that we have our angle. This is our inscribed angle. As you can see, it's got the vertex right here on the circle. And then here's a chord, and that forms the end that intercepts this arc down here. Okay? So vertex on the circle, and then the chords come through to create this intercepted arc. Now what we know about inscribed angles is that their measure equals 1/2 the measure of the intercepted arc. So as you can see with this inscribed angle, we've got our inscribed angle. That's our angle, and the measure of that is 40. The measure of our intercepted arc is 80. So we know that the measure of inscribed angles is half the measure of the arc. So let's take a look at an example. Again, guys, when you're doing these, pause the video, see if you can do it yourself, see how it goes, and when you come back, I will be explaining how to do it. You can see if your answer matches mine. So in this one, we take a look and we see that we have some inscribed angles. First one that I see here is with a known value is this one right here. And I know that my angle's 20, and I see that it intercepts this arc. We said in the previous slide that the angle, the inscribed angle, is 1/2 the arc. So that means my arc must be 40 degrees. So now I got to think, and I got to look, and I've got to say, okay, well, I've got my y here. My y is this angle right here. Well, if x is 40, and I'm told that this angle right here, this arc, I'm sorry, is 110, this angle intercepts that whole arc, which is 150. The angle is half the arc, so my angle is 75 degrees. I hope you did well on that one. Here's another one. Again, take a look, pause, see if you can come up with the answers. So first thing I see is that this angle right here is a central angle. What do we know about central angles? Central angles equal have the same measure as their intercepted arc. So that means y is 60 degrees. Then I see that I have this inscribed angle here for x. So I know that inscribed angles are half their intercepted arc. So then I know that x must be 30 degrees. So now I have to find z. So to find z, I look and I think, okay, well, here's a clue. This and that are congruent. Well, I know that congruent chords have congruent arcs. So I know that these two arcs are congruent. Again, pause if you need to pause to try to figure it out yourself. But what I see is that if I say 360 minus 60, I get 300 degrees left. And if I split that 300 between these two congruent arcs, then each of the arcs must be 150 degrees. Again, hope you got it right. First corollary, we've got a couple of corollaries coming up. So the first one says that if two inscribed angles intercept the same arc, then the angles are congruent. So let's see what they're talking about. I see this angle. I know that it's 20. It intercepts this arc. Alright, so that means that arc must be 40. And I also see that I have this angle right here that intercepts the same arc. So that means that x must be 20 degrees. Now y is this whole angle here. So let's see about y. What I see about y is that it is this angle and it intercepts that arc. That arc is a semicircle. That arc is 180 degrees. That means that y, being an inscribed angle, is half of 180, is 90 degrees. Well, look what comes next. It says an angle inscribed in a semicircle is a right angle. We just showed that. This is an inscribed angle. It intercepts the 180 degrees, therefore it must be 90. We also have this triangle down here, this angle here, that is inscribed in that semicircle, so it too is a 90-degree angle. Here's our third corollary. The third corollary states that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, let's see about that. Let's see. So here I have this inscribed angle. So I can find that x is 40 degrees. Well, I also see that this angle is inscribed in a semicircle, so I see that it must be 90, which means this angle must be 50. Cool. So if this angle is 50, then this one's 100, which makes sense because it's a semicircle and we've already got our 80 degrees. Alright, now this chord and this chord are congruent, therefore that arc and that arc are congruent, so this arc is also 100 degrees. That means that y is 50 degrees. So far we found x equals 40 degrees, y equals 50 degrees, but we're trying to prove that opposite angles are supplementary. Well, I see here that 50 plus 50 is going to be 100. And I know that this one's 40. I also know that this is 40 because I know that's a right angle. Again, it's inscribed in the semicircle. So that's 50 for that angle, 80 for that angle. They're opposite. They total 180. So there we have it. Alright, again, if you guys want to pause the video to try to figure out this one for yourself, then go for it. I'm going off that third corollary, and I'm going to be taking a look at these opposite angles. And that corollary stated that my opposite angles are supplementary. So now remember, guys, when you have a problem where you have a squared term like that, you're going to want to bring everything over to one side and set it equal to 0. So I'm going to end up with x squared plus 17x minus 200 equals 0. So I'm going to factor it. You guys, I think, use the box method. That's great. So I'm going to factor. I've got x times x. I've got to think of factors of 200 that equals 17. So I think 25. Oh, let's try that again. 25 and 8. That gives me 17. I need a positive 17. So my 25 will be plus and my 8 will be negative. So my final answer is x plus 25 equals 0, x minus 8 equals 0. So x equals negative 25 or x equals 8. I take a look at my two answers and I put them back into the problem to see if they make sense. When I put this negative 25 into either this one or this one, I get a negative number, and it doesn't make sense to have negative angles. So I reject negative 25, and my answer is x equals 8. Hope you guys did all right on that one. All right, here is another one. This one is our last one. So we're going to take a look at that, and we've got some given information here. And I'm going to see what this given information tells me. So the first thing I look at is I see, okay, I've got this 30 degrees on that inscribed angle. Intercepts that arc, so this arc is 60. That's good. All right, then I have this inscribed angle, right? And it intercepts this arc. So if that's 40, this one must be 80. All right, so that's helpful. So if this is 80, then what is x? 40 degrees. Now, looking at y, that one should be easy. I see that y is this angle, and it's inscribed in a semicircle, so it's a 90-degree angle. My last thing I have to look at is z. So I see that z is this angle right here, and it is inscribed, and it intercepts that arc. Well, I know that these two right here equal 140. So 360 minus 140 equals 220. So that means that this arc out here is 220. Z is 1/2 that arc. So Z is 110 degrees. There you have it. So what I'd like y'all to do tonight is page 2032, 1 through 10 all. That is due at the beginning of class. Just walk in, hand it to Mr. Medlin. And also remember that you have this quiz. It's over 12.1 through 12.3. It's a quick quiz. It shouldn't take the whole period. But you still might want to go back through your notes and the video lessons for 12, the video lesson for 12.3 and your notes for 12.1 and 12.2. And just make sure you remember some stuff. 12.4 will not be on it. You will have 12.4 homework for over the weekend that you will have due in class on Monday. So, that's it. Thank you very much. Be nice to Mr. Medlin.